Hey guys, welcome to my YouTube channel. I am Krishna Gopal. In this video, we are going to discuss about some questions which the interviewer can ask you in your interview from the normal distribution. Normal distribution is a very common distribution and everybody expect, at least in the data analysis, in the data science interview, that you should be familiar from the normal distribution. In this video, I'm going to show you some question, or I'm going to discuss with you some questions that directly can ask in the interview. So this is the new playlist which I am creating today will be the first video, and the first topic is the normal distribution. So let's start this video with the first question. So the first question is, what are the methods to check that data follow the normal distribution or not? Now if interviewer asks this question to you, so how you will reply the answer? So we can say, like, there are many methods to check the data follow the normal distribution or not. We can check through the data visualization also. So in the data visualization, we can draw the histogram, because histogram tell the spread of the distribution, how the distribution is behaving. What is a distribution? Distribution is basically a shape. So by plotting the histogram, we can see the spread of the distribution. But histogram is not the way to check the data follow the normal distribution or not, because in some cases when we have the less sample, the bean size changes. If you see, this is the blue color beans will change. So this is not a suitable method to check the data will follow the normal distribution or not. So inside the data visualization, the next method is quantile plot, that is popularly known as the QQ plot. So with the help of a QQ plot, if all the points are lies near to the straight line in both the ends, so you can say the data will follow the normal distribution. And if the points are not lies near to the line, like if you see in this picture, if both the ends are far from the straight line, so based on this visualization by QQ plot, we can comment that data will follow the normal distribution if we get the like this graph, and data will not follow the normal distribution if we get like this graph. Okay, because at the end, at the starting point or the ending point, you see the points are far from the straight line. Now when you are giving the answer in the interview, when you are discussing about the quantile plot, that is known as a QQ plot, so the interviewer can ask you here, do you know how to construct the quantile plot? Even before that, if we talk about what is a quantile, so we should be familiar what is a quantile. So quantile is a statistical property which can determine that how many points lies above that cutoff point and how many points lies below that cutoff point. So for your explanation, I will say here the median is a quantile, because median is a Q2. So 50% of the values lies in this side and 50% of the values lies in this side. So this is a quantile. So quantile is basically a statistical property. Now come to the quantile plot. So in the quantile plot, you have some points which you want to check that these samples follow the normal distribution or not. So you have to arrange all the elements in the ascending order. So that is your first step to construct the quantile plot. The second step is that you have to draw the normal distribution curve. Then third point, you have to calculate the Z value. Z is here the standard normal variate, that is a cutoff point in your distribution. So you have to calculate that Z value. Then plot that Z value on the x-axis and plot your order value which you saw it in the first step on the y-axis. When you plot these things, you will see a nice graph like this. Then determine all the points, the both starting and ending points also lies very close to the line or not. So if it lies close to the line, that means it follows the normal distribution. If it not lies near to the line, that means it does not follow the normal distribution. But that's what we are talking here regarding the data visualization. But in some cases the data visualization is not much more reliable. Okay, so we need here some statistical test which can give us the confidence. So to check the data follow the normal distribution or not, we have the first way for the data visualization, what we discussed, the histogram and the QQ plot. And in the statistical test, we have the two tests. One is the KS test and one is the Shipro-Wilk test. So both the tests we're going to discuss. So we're going to start from the KS test. So what is a KS test? So KS test is a way to check the data follow the normal distribution or not. But this KS test is not only for the normal distribution. It can check for the other distribution as well. So to perform the KS test, you need to build the hypothesis. So you have to build one null hypothesis and one you have to build the alternative hypothesis. So what the hypothesis you will build here, let me write the hypothesis here. So you can build the H naught, that samples are from the same distribution. And if you are checking here for the normal distribution, so you can write samples are from the normal distribution. But KS test is a general test. It can be applied to any kind of a distribution. So I'm just going to write here the samples are from the same distribution. So the samples are from same distribution. And you can write the alternative hypothesis like this, that samples are not from same distribution. So this is your first step to perform the KS test. What is the principle of KS test? So KS test use the two types of a distribution. One is a cumulative distribution function and one is the empirical distribution function. So you have to be sort the values in ascending order. Then you have to be calculate the CDF and you have to be calculate the EDF. So this is the third step, this is the fourth step. This CDF you want to check that the samples follow the same distribution or not with respect to the EDF, that is a empirical distribution function. So empirical distribution function is an estimate of the cumulative distribution function. So what you need to do, you have to build one hypothesis test, you have to be sort the values, you have to be calculate the CDF, you have to be calculate the EDF. Then after this fifth step, you have to be plot both the distribution together in the graph. So plot both the distribution. So plot both the functions. Then sixth step, calculate the vertical distance between them. So you have to be calculate the vertical distance between them. Then seventh step, you have to be calculate the test statistics. So in the case of the KS, it is your supremium of f n x minus f of x. This is your test statistics. Eighth, you have to be calculate the critical values from the KS table. So you have to find the critical value from KS table. Okay. And the next step, you have to be compare this critical value with the calculated value. And then state your opinion that you are going to reject the null hypo or you are going to accept the null hypothesis. What are you going to do? So that is your step 9. That is, you have to be compare the critical value with your calculated value in the step number 9 and you have to be state your opinion. So this is how the KS test works. Okay. So with the KS test, we have the another test that is known as the Shapiro-Wilk test. The Shapiro-Wilk test is much more powerful compared to the KS test because the Shapiro-Wilk test only tests for the normal distribution, whereas KS test you can apply for any kind of a distribution. So the next step is the Shapiro-Wilk test. This is the Shapiro-Wilk test. So this is much in the theoretical way, this is much more powerful compared to the KS test. We can apply this Shapiro-Wilk test only when we want to check the data follow the normal distribution or not. So we have the W, the test statistic in the Shapiro-Wilk test, that is the AI, and the XI, that is the square, and divide by I is equal to and xi minus x bar whole square. So here this xi is the ordered statistics we have. This is the ordered statistics. Okay. So this is the Shapiro-Wilk test and W is the test statistics for the Shapiro-Wilk test. So these are the two tests which can help us to determine that data follow the normal distribution or not. So what we discussed first the data visualization. In the data visualization we discussed the two things, one is a histogram and one is the this quintile plot. Then we come to your statistical test, because the data visualization is not always reliable to say that our data follow the normal distribution or not. So these are the two tests. One is the KS test. KS test can be implemented to any kind of a distribution, where the Shapiro-Wilk test only for the normal distribution, and the Shapiro-Wilk test is much more powerful compared to the KS test. So this is the way you can give this answer in the interview. If the interviewer asks you that tell us some method that the data will follow the normal distribution. So now move to the question number 2. Question number 2 is given a random Bernoulli trial generator, how do you return a value sample from a normal distribution? So to understand or to solve this question or to give the answer in the interview, you have to be understand here term by term. What is a Bernoulli trial? How we return the value from the normal distribution? Okay, so if this question asked in an interview and you not prepare this kind of a question from the normal distribution, then it will be you feel very difficult to give the answer. But if you do some question like this, then you can give this answer in an easy way. So first I explain you how you can break this question in the steps, and then we will solve this question. So we have the Bernoulli trial here. So I am writing the Bernoulli trial. Okay, suppose I have the n trials. So what is a Bernoulli distribution? Bernoulli distribution will tell either you are success or fail in a one experiment. Okay, whereas the binomial distribution will tell in the n number of times what are the chances of your success and failure. Okay, so here I am talking about the Bernoulli trial. So let us suppose we have the n trials, and all the n trials are the IID having a probability of success P. Okay, this much you understand from the question that we have the Bernoulli trial generator. Okay, so in the Bernoulli trial generator, I assume we have the n trials, and all the n trials are the IID having a success of probability P, and the failure is a Q. Okay, the Q is a 1 minus P. Okay, now we have the n trials, and generally general result what we have, if X is the number of success in a Bernoulli experiment with an independent trial, then its X distribution is same as the binomial distribution. That means this X distribution will be the NCX, PX, Qn minus X. And now when I know the n trials which are IID and whose distribution is same as the binomial distribution, I know very well this mean is, I know the mean of binomial distribution is NP and the variance is the NPQ. Okay. Now here I tell we have the n trials, and for the n trials I can calculate the sample mean. So what is my sample mean here? So sample mean is the 1 upon n summation xi, I is equal to 1 to n. So this sample mean, if I find here the expectation of x bar, I can find here expectation of summation xi. Okay, and I know the expectation of xi is the NP. Expectation is same as the mean, so I can write here the NP, so I can get the value of n. Oh sorry, I will get the value of P. Similarly, I can calculate the variance of x bar. So variance of x bar is the variance of 1 upon n summation xi, then it will become the 1 upon n square into variance of x bar is the NPQ. Okay, so I will get here PQ by n. So I get the expectation, I get the variance. Understand? Okay, so we find the expectation of x bar is the P and the variance of x bar is the PQ by n. Now again I am assuming that n is large. Okay, n is very large. So by applying the CLT, by using the central limit theorem, I can say that my sample mean will follow the normal distribution with mean P and the variance is PQ by n, and therefore I can calculate the standard normal variate for my sample mean, that is the x bar minus P divided by PQ by root n. So this is the way how we can take the values from the normal distribution when we have the Bernoulli trial generator. Okay, so let me explain this is the again. So what is the question? We have the given a random Bernoulli trial generator, how do you return a value sample from the normal distribution? So what I do here, I tell the Bernoulli trials we have. Okay, so I assume the n trials which are the IID having a probability of success is P. Now I have the result. If X is the number of success in the Bernoulli experiment with an independent trial, then its distribution is same as the binomial distribution. So I know the binomial distribution mean is the NP and the variance is the NPQ, and we have the n trials, so I can find the sample mean from this population. So the sample mean is 1 upon n summation of xi. Then I can find this expectation of x bar, that is will come p, and the variance of x bar will come the pq by n. Now I assume n is too much large. So n is large, and by applying the central limit theorem, I can say that my sample mean follow the normal distribution with mean p, and your variance is the pq by n. So therefore I can calculate the z value as x bar minus p divided by pq by root n. So like this way you can give the answer by solve this question in a paper. So I think this question clear to you. If you like this question, let me know in the comment section if this question is not clear to you, and let me know again in the comment section if you want some question like this, so you will be more confident to give the answer from the statistics question in your interview. But this question mostly the companies like product based companies only will ask, which will check your statistics knowledge, how much knowledge you have. This question will not come to the data analysis interview. Okay, so move to the third question. Third question is my favorite. Even this question I face in my interview many times. So what is the third question? What will happen if error in the linear regression does not follow the normal distribution? So first we should know there is an error in linear regression. So when we write the equation, is the y is equal to beta naught plus beta 1x plus epsilon in the linear regression, and we assume this epsilon follow the normal distribution. Now my question is, if what will happen if this error will not follow the normal distribution, then what will happen in a linear regression? Because it is one of the important assumption in linear regression, and now I am violating it. So what will happen? We build some hypothetical test and the confidence interval to estimate the beta naught and beta 1. These are the two coefficients in the linear regression. So we build the hypothesis test and we build the confidence interval also. Now when we lose the normality, so our distribution become the skewed. So the confidence interval will not give the accurate result. And to know the more detail about this question, what you can do, this question I discuss in my first video of my YouTube channel. So you can go and watch that video. I will be put that video link in my descriptions, and I explain like 10-15 minutes about it, so you can understand more clearly in that. Okay, so up to the third question is clear. Now move to the question number 4. So question number 4 is very basic question. This question I'm pretty sure this not come in an interview, but let's go through what's the question. What are the properties of a normal distribution? So everybody know the properties of normal distribution. The mean, median, mode are equal if the distribution is a normal. If distribution is normal, then only mean, median, mode is equal. If mean, median, mode is equal, we can't say the distribution is a normal. We have some distribution whose mean, median, mode is equal but does not follow the normal distribution. If we have the normal distribution, then we can say the mean, median and mode are equal. Second point, the normal curve is a bell shape and the symmetrical about the mean. These are the two properties of a normal distribution. Now go to the question number 2. Do you know some distribution that are the symmetrical except normal distribution? Yes, there are some distribution like the uniform distribution, Cauchy distribution, Laplace distribution. They are symmetrical, but they are not a Gaussian distribution. They are not the normal distribution. Okay, the question number third part is interesting. If random variable x has mean 0 and standard deviation 1, then x follow the normal distribution. Not necessary. I like the question number 4, like the part number A. If we have normal distribution, then only mean, median, mode is equal. Similarly, if we have the standard normal distribution, I have to say here, then only the mean is 0 and variance is 1. It's not like we have some random variable whose mean is 0 and standard deviation 1. That means it follows the normal distribution. No, it's not. Okay, so these are the 4 questions I cover in this video. Okay, these are the symmetrical uniform distribution, which is symmetrical, and the Cauchy distribution, which is the symmetrical. I hope you like this video and you like this 4 question, and if you like this effort, then please like, share and subscribe to my YouTube channel. And if you want some question like question number 2, then also let me know in the comment section, so I can get some question and I can explain you. And if this question is not clear, then also let me know, so I can explain you in the more clear way. I hope you like this video. If you like this video, then please like, share and subscribe to my YouTube channel, and we'll meet you soon in the next video with another topic. Up to that, thank you, take care, bye bye.